Okay, we're doing naming of acids and bases. So we're going to talk very, very generally about what an acid is and what a base is. We don't dive too deeply into acids and bases in this class. You'll get into them much deeper in college chemistry, but we'll talk about just a basic introduction of what an acid is and what a base is. Okay, and then more specifically how we name them. So acids are a type of covalent compound. Okay, so we'll talk about acids first because bases are pretty simple. Acids are a covalent compound. And they are known as proton donors. Okay, they can be known as proton donors, or they could even be known as electron acceptors. Okay, but our definition makes more sense as proton donors. Okay, so I want you to be able to think of them as proton donors. Okay, and so when we say a compound is able to donate a proton, we talk about protons in chemistry as a hydrogen ion. Okay, a hydrogen ion. If I have hydrogen as its ion, it's H+, right? Because hydrogen's charge is +1. Would we all agree with that? So if we have a hydrogen ion, which is H+, how many protons are in that atom? 1. How many electrons are in that atom? Right, if we're at a +1, that means we have 0 electrons. How many neutrons are in that atom? Look at hydrogen's atomic mass. Right, if hydrogen's atomic mass is 1 and its proton is 1, that means we have 0 neutrons. Okay, does that kind of make sense? Proton's atomic mass is 1. If hydrogen's atomic mass is 1 and its atomic number is 1, it means it has no neutrons. So when we talk about a hydrogen ion, that's essentially just a proton. All it is a single proton. Okay? So when we talk about proton donors, we talk about acids having hydrogen ions attached to them. Okay? So acids are specific covalent compounds that have hydrogens on them. Mm-hmm.
So for like hydrogen, would there not be a proton?
Hydride would have just extra electrons. So hydride would have 2 electrons and still 1 proton. Okay, because if we change the number of protons, that changes the element altogether. So hydride would just have an extra electron. And it's pretty unlikely that happens. It's rare that happens. But yeah, good question. Okay, so when we talk about proton donors and proton acceptors, we're talking about hydrogens moving back and forth. Okay, so if an acid is a proton donor, what do you think that makes a base? A proton acceptor. Okay, so a base, you can write that separately as a proton acceptor, right? And we're not going to dive too much into acid and base theory beside that, right? We need to know that acids can donate protons, bases can accept protons. Okay? Other than that, we're going to get into the naming of acids. Naming bases is really simple, so we'll cover that at the end. But naming acids takes a little bit more effort. Okay. So when we talk about acids, there's 2 different types: binary acids, which means it's probably how many elements? Okay, right. These are 2 elements, so usually consist of 2 elements. Okay, and what should one of those elements be? If it's an acid, what does one of those elements have to be? Okay. If we know that acids are proton donators or donors, and we know that hydrogen ions are our protons, that means binary acids need to have hydrogen, right, and some other element, right? If it's got to consist of 2 elements, one of those elements has to be hydrogen. Okay? Usually the other element is a halogen. Okay, which is group 17. Okay, it's not always a halogen, but that makes the most common version. Yeah, what'd you say?
No, it's not right.
Tell me one more time. Yeah, iodide, bromide, chloride, fluoride, those are all halogens.
Okay, what were you doing?
I don't know.
Did it just
All right, so binary acids and acids in general, unlike regular covalent compounds, acids have to have a neutral charge. This one has to have neutral charge.
binary?
Well, all acids in general. Yeah. So when we start looking at these, we're going to have to balance our charges, right? Hydrogens are always a +1 because that's our proton that we're donating or accepting, and then we need to balance the other side of it. Okay, so acids are easy to balance because hydrogen is always +1. Form an acid between hydrogen and chloride. How many of each of those do I need? What are the charges? Yeah. +1 and -1. Okay, so that means my acid, it looks like this, HCl. That's it. Okay, and with acids, the hydrogen always goes first. Always, always, always.
Is that hydrochloric?
Yep. Okay, so this example, HCl, is called hydrochloric acid. Okay, and I'll give you some rules here for how we name these. That's called hydrochloric acid. Okay, so that's an example of a binary acid. We could also form a binary acid between hydrogen and sulfur. Okay, how many hydrogens would we need to balance out that sulfide? 2. So it would look like this, H2S. Okay, can anyone take a guess as to what those would be called?
How is this different from, how would you tell that that's different
From a regular compound.
yeah.
Okay, so an ionic compound is always a metal and a nonmetal, and so in acids, hydrogens always come first, not a regular metal, right? Since hydrogen's not a metal. It sits on group 1, but it's not a metal really. So in acids, hydrogen will always come first.
So that's how you tell.
That's how you tell.
Okay.
Okay, so this one would be called hydrosulfuric acid. Okay, so I'll give you some clues as to how we determine if it gets a hydro and what it should end with and all that kind of stuff. Okay, but that's the introduction for binary acids. So even though this isn't a halogen, that's okay. It's still hydrogen plus one other element. That's what makes it a binary acid. Okay? The other type of acid that we could deal with is called an oxy acid. What do you think has to be contained in an oxy acid? Oxygen, right? It has to have hydrogen, oxygen, and one other element. Okay, and oxyacids actually usually come from our polyatomic ions, so like phosphate, nitrate, carbonate, whatever it is. Okay, usually they come from our polyatomic ions. Okay, so an example of an oxy acid, let's say I wanted to make an acid from hydrogen and sulfite, SO4 minus 2. Okay, how many hydrogens would I need to balance out that sulfite? I need 2, so it would look like this, H2SO4. Okay. This one is called sulfuric acid. Okay, so there's a difference between hydrosulfuric acid and sulfuric acid, and we're going to look at the difference between how we have these endings and prefixes and all that kind of stuff. Okay, if you turn to your book on page 230, I want you to look at a couple things on page 230. Okay, so let's look at all three versions if we were dealing with phosphorus or phosphate or phosphite. Okay, so I'm going to say H3P, H3PO3, and H3PO4. Okay, all of these are different acids, so I want the names for each of these acids. Okay. Okay, so the way we determine how we name it is we figure out what anion does it come from. So if I take away my hydrogens, right, if I donate my hydrogens, that would be 3 hydrogens, and it would leave me with P minus 3. So what anion is this? Phosphide. Which means what should our acid be named? Yeah, this one is weird. Phosphoric. It gets to keep the OR in there, not phosphic acid. Some of them do, some of them don't. You just have to kind of get used to the rhythm there. Hydrophosphoric acid. Okay, because it comes from an IDE anion, that means we should end up hydroic acid. Okay, does that make sense on your sheet that I handed you? Okay, since it comes from an IDE, which is the bottom one, it should be an hydroic acid. Okay. So the next version of phosphorus that we're dealing with, we take them away or we separate them. That leaves us with H plus, right? 3 H pluses really. And it leaves us with PO3 minus 3. What polyatomic ion is that, or what anion is that? That's phosphite. Oops. Which means our acid should be called that's right, phosphorus acid. Phosphorus acid. Okay, and our last one here, if we separate it, leaves us with 3 H pluses, and it leaves us with PO4 minus 3, which is phosphate. And that means our acid name would be phosphoric acid. Okay, so remember how I told you memorizing your polyatomic ions is important? It's very important. If you're trying to name an acid and you don't even know what this polyatomic ion is, you won't be able to name the acid, right? So having your polyatomic ions memorized is important. Okay, it will help you throughout the whole rest of your semester. Okay? Questions about our labels? If we took away our hydrogens, if we donated our hydrogens, which is what acids' jobs are, if we donated our hydrogens, that would leave us with PO4 minus 3. Okay? Okay. Because this was our starting compound. So if we get rid of our hydrogens, that leaves us with a minus 3. Okay? It's just like naming ionic compounds. So basics always have hydroxide. So when we have sodium hydroxide, like that's it. You already know how to name bases. Yeah, so we'll review it a little bit, but naming acids is much more intense than naming bases. All right, let's try a couple here from the name to the formula. So I'm going to give you the name, you're going to give me the chemical formula. Oh, I said I was going to give you the name. All right, give me the name on that one. I'll give you the name on the next one. Oh my, I'm losing it. So this first one, I want you to give me the name. Second one, I want you to give me the formula. And shut your book, so you're not just looking in your book. Would we agree? No, this is good. Perfect. Perfect. That's right. So if chlorite is a minus 1, we added 1 hydrogen to help balance, so now we have a neutral charge. Okay? So if we took away our hydrogen, right, if we donated our proton, that would leave us with ClO2 minus, which is chlorite, which means we have an OUS acid. Okay, how do we feel about acid naming so far? Okay? All right, naming bases are very simple. Okay, naming bases, extremely simple. They are proton acceptors. Okay, that just means they have the ability to take on a proton. And bases usually have an OH in them. Okay, and what polyatomic ion is OH minus 1? Hydroxide. So if I give you KOH or NaOH or MgOH2, those are all bases. Okay, so you name them just like you name regular ionic compounds. Potassium hydroxide, sodium hydroxide, magnesium hydroxide, right? Naming bases is no different than naming regular ionic compounds. Okay, so there's not much there that we need to reiterate about bases, but bases usually have this OH in them. Okay, and the reason for that is if we had, let's just see why this would make a base. NaOH, okay, and sodium goes away. That would leave us with OH minus. And what do you think OH minus wants to take in? A proton. And what do acids usually give away? A proton. So that forms water. Okay, so that's why bases have an OH, okay, because they'll get rid of their metal and they'll take on a proton, to be happy. Okay, but bases usually have OH, so naming bases is simple, usually just OH in them. Okay. All right, so now I'm going to give you formulas. I'm not going to make you go from words to formulas yet. We'll go formulas first. You have to determine, is it ionic, covalent, or acid, and then you have to name it correctly. Okay, got it? All right, let's see here. So the way you name it tells me if you know it's ionic, covalent, or an acid. So you don't have to specifically tell me ionic, covalent, or acid, but the way you name it will tell me if you know. Lead 2 nitrate. How many of you had that word for word? Lead 2 nitrate. Perfect. That's what we should have. Good. Okay, we know it's lead plus 2 because we need 2 nitrates to balance it out. How many of you just forgot the Roman numeral? Okay, lead 2 nitrate. Ionic, covalent, or acid? What do we think? Ionic. Oh, sorry. The first one, ionic. Okay, second one, ionic, covalent, or acid? This one is an acid. Okay. So, anyone want to try to volunteer its name? Yeah, John?
Acetic acid.
Good. Acetic acid. Not that you would know how to pronounce that, but that's okay. Acetic acid. Acetic acid is what vinegar is made out of. Okay, so acetic acid smells like vinegar. Vinegar is just watered down acetic acid. Okay, so that's how you know. Now you can go home and tell your mom, can I have some acetic acid? I need to clean something. Okay. Last one, ionic, covalent, or acid? Covalent. Okay, Sam, what'd you have? Dinitrogen pentoxide. Raise your hand if you agree. Perfect. Good job. Good job. How many of you went 3 for 3? Good. All right, good. Okay, let's see here. Agreed. Yeah. Okay, perfect. H2SO3. Sulfurous means it needs to come from what anion? Sulfite. Good, so we need to combine hydrogen and sulfite, which we did. Good. Copper 1 bromide. Carissa, what'd you have? Cu. What'd you say? Okay. CuBr, right? Bromide is a -1, copper is a +1, so it's an easy balance there. Hydriodic acid. Katie, what'd you have? Okay, that's it. Perfect.